Hi, everyone. My name is Nick Schrock, the founder of Elemental, the company behind Dagster. First of all, thanks to the Airbyte team for inviting me to speak, and thank you all for taking the time to listen. The prompt for this talk was, what would you put on a billboard? Which I thought was a great prompt, and I was excited to give the talk. And my immediate answer was data processing is software engineering. So what do I mean by that? First, the term data processing. It's the core of data, ML, and analytics. We define it as building computations that consume and produce data assets. Working in a drag and drop tool like Informatica is data processing. So is building a Spark job, a DBT model, or an ML pipeline that happens to live in a notebook. You might be asking yourself, is that question actually a controversial one? And the answer is yes. And the discussion around it is actually quite subtle. It's a question that's been a constant in the data community for decades. And the answer is ebbed and flows with the underlying reality, both technological and economic. The not engineering argument is this: the domain is constrained enough that one can build tools that empower less technical users by allowing them to use graphical tools that live outside the traditional software engineering process. This takes the form of tools like Informatica that enabled core ETL work and drag and drop interfaces, or say enabling data processing and tools like Tableau in order to enable self-service analytics by technical users. We actually predict that there'll be a renewed pressure in this direction as in our kind of new, more depressed economic environment. There'll be a pressure to cut costs. Engineers are expensive, and empowering less technical users to replace engineer would appear to be a way to, quote, do more with less. We think that this is a step in the wrong direction. Data processing has never been more critical to the enterprise. Users, both internal and external, have never been more demanding, and the complexity of the underlying problem has never been higher. The way to manage this complexity is to adopt software engineering processes. Not doing so will actually dramatically slow down everything in enterprises over the medium term. There are always domain-specific concerns that do not fit in with within the constraints of the no-code tool. That's why they almost always end up with text boxes inside of them where you can type code and save it without any change control or process. This is a disaster waiting to happen and leads to fragile, untested systems. Now, are we saying that only engineers should do data processing? Absolutely not. There's a famous article called Engineers Shouldn't Write ETL from 2016 that we actually heartily agree with. It argues that domain experts like data scientists should write their own pipelines and own the entire process end to end. However, it's worth noting that in this article, he refers to data scientists, quote, writing code and the essential relationship between platform engineers and those data scientists. Critically, those data scientists must be incorporated into a software engineering process. So the statement here is actually a more accurate, expanded, but less catchy version of the title of this talk. It says that data processing should be done in the context of a software engineering process, not that it needs to be done by software engineer. And the difference here is critical. I think a concrete example really helps. DBT has been a leader here. It's really been obviously a extremely popular tool in the data community. And their success has not been low code or no code, even though sometimes people refer it to that. The genius of DBT is that they were able to incorporate analysts into a software engineering process, making them more productive and leveraged. So even those who are nodding their heads at the claim that data processing is software engineering will probably also nod their heads at the statement that this all still seems pretty broken. There's been an enormous amount of progress over the past few years, but we're still at the beginning of this journey. I'd say that data processing is still a decade behind mainline application development in terms of tool quality and productivity levels. Productivity in software is a profound thing. It's not like industrial productivity, where one can make widgets more quickly and efficiently. Productivity in software compounds. It's about making entirely new things possible by raising the abstraction level and unburdening the mind of the practitioner. So I grabbed this picture off the internet, so I apologize for its grotesque color scheme, but the key insight is this: errors and defects caught earlier in the development lifecycle are orders of magnitude less expensive in terms of time spent and pain incurred. Would you rather catch an error while developing on your laptop or when you get an on-call alert over the weekend? I think the answer to this question is obvious. Shifting left in data has been very hard to do because there are different constraints at play than in traditional application programming. This is a huge topic and could be discussed for hours on end, but I want to focus on two aspects in particular. One, in today's world, data processing has dependencies on cloud native infrastructure, which cannot be feasibly mocked or simulated anywhere except in the cloud. Practitioners write code that executes in that infrastructure and is highly coupled to it. Simple way to put it, you can't run Databricks or Snowflake on your laptop. The other aspect is that data processing relies on data you don't control, and that is incredibly hard and expensive to recreate. Efforts to abstract away both of these problems leads to the same outcome, which is that the development environment is too expensive to maintain and is too different from the production environment to be useful. Eric Bernhardson memorably wrote up a post about this in 2021 called Software Infrastructure 2.0, a wish list. It's worth a read, but one of its takeaways can be very efficiently communicated in a meme image. So the midwit in this image is trying to abstract away both infrastructure and simulate production data. And what the midwit is saying here is that or what he's not saying is that in reality, it's a fool's errand when taken to its extreme. There's just too many differences between your development environment and production. So as I stated before, data feels behind software engineering and application. What are those folks doing to solve similar problems? The answer is that they are starting to branch everything, and bringing this to data is an enormous opportunity. One beloved technology in front end is Vercel. And maybe its killer feature is called preview deployments, which is on every PR. It creates a fully isolated deployment of the website that has the code that's in that PR. It's essential to our internal processes. It's an amazing transformative workflow. This trend is also appearing in operational databases. Trending databases like Neon.tech and PlanetScale offer native branching of the database. One can apply schema to a branch of the schema, test directly against them, and then merge those schema changes once the change has been verified. This trend is nascent in data, but it has enormous potential. And the insight is this: in order to develop against prods safely, you must be able to deploy code to a branched environment and operate against branched state. It's really a profound shift in the way you develop. Snowflake's actually a leader here. So they don't call it branching, and I think they should, but they have this wonderful feature called cloning, which in effect brings native branching to the data warehouse. You make a clone of a schema or a database, it's a copy on write, so it's cheap, and then you can safely operate against it, and only when you mutate it does it actually do anything. So, and it doesn't affect the parent database, the prod database. So you can safely develop against prod data. It's an amazing innovation. We at Dagster are moving in this direction as well. We have a feature called branch deployments in our cloud product, which on every PR, we push your code to cloud and create a lightweight staging environment that has the code in your PR. One can use the operational tools that come with the orchestrator to kick off runs and inspect the result. There's also this additional advantage in running this orchestrator, as the orchestrator itself can be used to manage the branch environment. So for example, when you can configure it to push up to Dagster Cloud and then actually run code that clones that Snowflake schema automatically. And it creates this really seamless, unprecedented workflow. The branch deployments and environments, in effect, create a new phase of the software development lifecycle in between local development and traditional heavyweight staging environments. The old model of only local development and staging, we were really severely limited in what we could shift left, and effectively a new phase has been invented. I think one of the most exciting developments about this approach is that it makes the core, not just the core data platform engineers more productive, but it can bring in more stakeholders and practitioners into the software engineering process. Combined with native GitHub editing, we actually have seen users who can effectively develop in Python in a data platform and test it without even setting up a local Python environment, which is a complete game changer. We really think this is just a start here. With the power of this workflow, we think native branching can come to all services in the data platform: ingestion, BI, notebooking. Imagine an environment where you can branch a notebook and then itself operate against the branched environment in the data platform. In this future, data platform teams can provide this effortless, seamless workflow across their entire platform, and it's super exciting. Thank you, everyone, for coming to this presentation, and I hope you agree with me that the future is indeed branched.